When you stop and think about it, the sheer scale of air travel today is just incredible. I mean, you've got thousands of planes, millions of people crisscrossing the globe at any single moment. From the ground, it might just look like a bunch of random white streaks in the sky, right? But what's really going on up there is one of the most precisely choreographed performances on the entire planet.
I bet you've had this exact experience. You're looking out the airplane window and you see another jet just cruising by, maybe a few thousand feet below you. And you can't help but wonder, right? Who's the person making sure we don't get too close? Who is the invisible conductor for this high-stakes ballad in the sky? Well, the answer, of course, is a super complex system of rules and, most importantly, people. We call it air traffic control. And here's the thing. As our skies get more and more crowded every year, understanding how this system works isn't just, a fun fact. It's absolutely crucial for keeping everyone safe and sound up there. So, to really pull back the curtain and see how it all works, we're not just going to talk in generalities. Nope, we're going to look at the actual rulebook. We're diving into the official coordination procedures for a real place, the Vientiane Flight Information Region in Laos. This is the document that tells controllers exactly how to manage the sky. So let's get into it. All right, first things first. To understand this, you have to stop thinking of the sky as just big and empty. Air traffic control doesn't see it that way at all. For them, it's a structured, three-dimensional highway system. It's divided into layers and sectors, and every single piece has its own manager. And to make sure everyone's speaking the same language on this highway, they use a standard unit for altitude. It's called a flight level, or FL for short. It's actually super simple. You just take the altitude in feet and chop off the last two zeros. So if you're at 20,000 feet, you're at flight level 200. Easy, right? It's the universal language of the sky. So using that system, the sky is basically split in two. Think of it like local roads versus the interstate. Everything from the ground up to FL 200, that's 20,000 feet, is called the lower airspace. This is where regional approach controllers handle the tricky stuff like takeoffs and landings. Then everything above that is the upper airspace. Those are the high-altitude superhighways, and they're managed by a bigger organization, the Area Control Center. And if we zoom in on that lower airspace, those local roads, it's broken down even more into what are basically neighborhoods or sectors. In the area we're looking at, there are four main ones: Vientiane, Long Prabang, Xiangkwang, and Paksay. Each one handles the traffic around major airports. And here's the cool part. Each has its own dedicated radio frequency. It's literally like having a direct phone number for the controller of that specific neighborhood. Okay, so we've got the map. How does an actual flight navigate it? Let's follow a single plane on its journey, right from the beginning. We'll say it's departing from Vientiane's Wate Airport. And you might be surprised to learn that this whole process starts long before the wheels ever leave the ground. Yeah, everything here follows a very, very precise sequence. Get this. 20 minutes before departure, the airport tower has to call up approach control and get permission. It's called a clearance. Only after they get that okay can the tower tell the pilot to start the engines and taxi. Then, once the plane is on the runway and ready to go, the tower gives the final takeoff clearance. And the very second that plane is airborne, bam, control is instantly handed over from the tower to approach. And that clearance request we mentioned, it's not just the tower saying, hey, can we go now? Oh no, it's a whole packet of crucial data. You've got the flight's ID, where it's leaving from and where it's going, the type of plane, when it's supposed to leave, the altitude it wants to cruise at, and this unique 4-digit code called a squawk. That squawk is what lets radar identify the plane as a specific dot on the screen. Every single piece of this is absolutely essential. And listen to how this sounds in the real world. This is the actual lingo. It's so incredibly concise, right? But in that one single sentence, the tower has told approach everything they need to know to approve the flight and slot it perfectly into the system. There is absolutely zero room for confusion. Okay, so the plane is up in the air. Now, as it flies through all those different sectors we talked about, those neighborhoods, it has to be passed from one controller to the next, like a baton in a relay race. And this right here is the absolute heart of air traffic control, the art of the handoff. So let's go back to our flight. We'll call it LA0401. It's airborne, and it's leaving the Vientiane sector, flying towards a specific navigational point in the sky called Jampa. Now, as it gets close to the edge of that sector's boundary, the Vientiane controller knows it's time to hand it over to the controller in the next neighborhood, which is Xiangkwang Approach.
This is how the Vientiane controller kicks off the handoff. They get on the line and use this exact phrasing. They're saying, "Hey, Xinhuang, this is Vientiane. I have flight Lao 401 and ATR 72. It took off at 0805. It should be at your waypoint Jampa at 0820 at flight level 130. He's all yours once he hits Jampa." It's a perfect, complete snapshot of everything the next controller needs to know. But the response is maybe even more important. The Xinhuang controller doesn't just say, "Got it," or "okay," no way. They read the entire message back, word for word. This is called a readback, and it is a non-negotiable safety check. It confirms without a shadow of a doubt that they heard and understood every single critical detail. Now, this might seem a little repetitive, right? A little overkill? But it is the absolute bedrock of the entire system's safety. This back and forth is a verbal contract. It guarantees that at every single second of a flight, there is one and only one person who is 100% responsible for that aircraft's safety. There are no gaps, no "I thought you had it," ever.
So let's take a step back for a second. Why all this trouble? Why is it so complicated? Well, because this whole intricate web of rules and sectors and very specific communication, it creates this powerful, unseen safety net that is protecting every single flight in the sky. And this whole thing isn't just about getting planes off the ground. It works in reverse for arrivals too. Controllers are constantly choreographing these arrival sequences, creating these perfectly orderly lines of planes in the sky, all waiting for their turn to land. It's how they manage the flow of traffic into a busy airport without it turning into total chaos. But the system isn't just a rigid robot. It's smart, and it's flexible. It has a built-in priority list for special cases. So if a flight is in distress, or if it's a medical flight, or a search and rescue mission, they get to jump to the front of the line. The system is designed to handle real-world emergencies and give priority where it's needed most. So, at the end of the day, it all boils down to three main goals, the three pillars of air traffic control. Number one, and this is the big one, safety, just keeping all those planes away from each other. Number two, order, creating an efficient, orderly flow of traffic so it's not a free-for-all. And number three, capacity. By doing the first two things really well, they can actually help airports handle more flights safely. Safety, order, and capacity. That's the whole game.
So the next time you're on a plane, buckled in and looking out that window, maybe you'll see things a little differently. Your journey isn't just a simple line from point A to point B. It's a carefully managed path through this incredible, invisible highway system, guided by a whole network of voices and rules, all working together in perfect harmony, just to choreograph your safe trip through the skies.